Good day, class. So this will be our module 4, analysis of structures. So but the basic principles and techniques of statistical analysis has been discussed in module 3. So in module 3, you have learned to compute yung resultant forces. You have learned to compute yung force na nag-act or yung reaction force na nag-act sa ating structure. So ngayon, in module 4, i-analyze natin yung buong structure. So the concept will now be extended to the determination of how the loads applied to a structure are distributed throughout the structure. Kung paano na-distribute yung forces natin throughout the structure. So among these structures are trusses, frames, and beams. So it is concerned more on sa ating determination ng external and internal forces na nag-act dun sa buong structure natin. Okay? So yung i-discuss natin will be, first is yung trusses. So we will be analyzing construction trusses. So ano ba ang truss? So a truss is a structure composed of members fastened together in such a way as to resist change in shape. It is a rigid structure. The term rigid being used here to indicate that the truss will not collapse. So an example of a truss is shown in figure 4.1. So ito yung example ng ating truss. So before that, yung truss, kadalasan na itong nating nakikita sa mga bubong. So we have roof truss. And sa bridges din. So meron tayong yung mga ibang bridge dito sa bansa natin, yung iba is made up of truss. So yung tinatawag na bridge trusses. Okay? And isa pa, pwede nating makita yung trusses kapag merong mga tower, like yung mga tower ng electrical, no, yung mga malalaki. So that is composed of trusses, or yung mga tower ng smart, PLDT, globe. So they are composed of trusses. So ito yung example ng isang truss natin. This is a plain truss. So itong truss, sabi niya dito, this truss is composed of 13 members. So isang member, example ito, member A and B. So this is considered one member. This member AB. Member BD is considered one member. Okay? And the bars making up the truss are called members, and the connection of the end of each members are called joints. So we have the joint B, joint D, joint E. So yung nagko-connect sa kanila, so that is called joint. So it is pin connected. So truss are considered pin connected. Okay? And then the upper chord is made up of bars BD and DF. So we have the upper chord kung saan yung nasa top ng ating trusses. So that is called top chord or upper chord. So itong member BD and member DF. And the bottom chord naman is made up of the 4 bars AC, CE, EG, and GF. So in truss, meron tayong top chord, bottom chord, and web members. So top chord, yun yung mga nasa taas. Bottom chord, yun yung mga nasa baba. Yung AC, CE, and so forth. And we have the web members or yung mga diagonal members ng ating truss. Diba? Kung nakita kayo sa mga gym, yung mga bubong ng gym, that malalaking trusses yun. So makikita nyo, meron siyang top chord, bottom chord, and meron siyang web members. Okay? So, a truss is an effective structures for carrying large loads that acts at the joints and which lie on the plane of the truss. Massive loads that cannot otherwise be supported by beams of realistic dimension can be carried safely well-designed truss. So, katulad yung sinasabi ko kanina, truss is an effective structure for carrying large loads. So, yung example yung sa gym, yung roof truss ng gym, malawak kasi yung span niya, di ba? Yung length ng kanyang span. So, kaya yung truss is very effective para i-carry niya yung bubong. Okay? Let's continue. So the determination of the forces acting on the members of a trust is simplified by the following assumption. So ito yung mga assumptions natin in analyzing construction trusses. So the members are joined together at their ends by smooth pins. So katulad ng sinabi ko, trusses are yung member ng trusses is considered joined together by mga pin. So pin connected siya. So sa actual na practice, members at joint are usually riveted or welded to a plate called a gusset plate. So in actual practice, so it is riveted or bolted siya. So ito yung member ng truss natin and ito yung joint niya. So pwedeng naka-welding ito or naka-riveted siya. Okay? So the weight of truss members is negligible in comparison with the applied loads. And all applied loads act at the end of the members. So yung load na nag-apply sa ating members is nag-act lang siya dun sa end. Okay? Sa end ng ating members. So it follows from the foregoing assumptions that every member of a truss is a two-force member. And therefore, the force acting at each end of the member will be directed along the axis of the member. So a two-force member is a member held in equilibrium by only two forces. So in the actual design of a truss, it is important to state whether the nature of the forces is tensile or compressive. So dalawa lang yung magiging nature ng ating force na nag-act sa ating member ng truss is it will be either compression or tension. Okay? So compression members must be made thicker than tension members because of the buckling or column effect that occurs when a member is in compression. Okay? Tension arrows are always indicated by an arrow away from the pin and compression by an arrow toward the pin. So, example, meron tayong truss and kapag compression, yung force na nag-act sa ating member, so yung force is towards dun sa pin. Okay? And kapag yung sa member naman is ang nag-act doon is tension, so always away from the pin yung ating direction ng ating force kapag tension. So class, dalawa lang yung magiging nature ng ating forces na nag-act sa member ng trusses. So is either compression or tension. Okay? So kapag compression, towards dun sa ating pin, sa ating joint, and kapag tension, away naman sa ating joint. So tensile forces elongate, stretch the member, whereas compressive forces compress it. Okay? So kapag compression, kinocompress niya yung member natin. So katulad ng nandito sa figure natin. And kapag tension, ini-stretch niya naman yung ating member. Okay? So let us proceed sa pag-a-analyze ng ating trusses. So in analyzing construction trusses, meron tayong dalawang method. So first is yung method of joints. So in this method, free body diagram of the joints or pins are constructed, usually after the reaction at the supports have been determined. So each pin is in equilibrium under the action of a concurrent force system. So sa method of joints, every joints is ina-analyze natin siya. Doon tayo bubuo ng equation based on sa ating equilibrium equations based dun sa natutunan natin dun sa mga past modules natin. So sabi niya dito, it is preferably first isolate those pins where the number of unknowns does not exceed 2. So consistency must always be maintained using Newton's third law of motion. So yung third law of motion ni Newton is yung kapag merong action, there is equivalent reaction. So i-isolate natin yung bawat joint. So after nating ikunin yung ating reaction, so example, we have this trusses. So find the actual forces in the members of the truss shown. So we have a truss here. And yung first na gagawin natin is kukunin natin yung reaction niya. So meron tayong reaction sa A and meron tayong reaction sa E. Okay? And para ma-determine natin yung mga forces na nag-act sa members. So ano yung members natin? Member AB, member BC, member CD, and member DE. So yan yung top chord natin. And bottom chord natin will be member AF, FG, GH, and HE. And we have the web member, which is yung BF, BG, GD, and DH. So, yung required natin to analyze, kailangan malaman natin yung mga force na nag-act sa ating bawat member. So, para makuha natin yon, first, kukunin muna natin yung ating reaction. Okay? So, first is sa truss is meron tayong reaction dito sa A. So, this is pin connected. So, magkakaroon tayo dito ng A vertical and magkakaroon din tayo dito ng A horizontal. And for support E, so this is a roller support. So, magkakaroon lang tayo ng reaction sa E, which is yung upward lang. Okay? Kasi it is free to move horizontally. Okay? So, let us compute para dun sa reaction ng ating trusses. So, summation of forces horizontal is equal to 0. So, going to the right is positive. So, that will be AH. So, kung makikita nyo, yung given natin is wala siyang, yung given loads natin is walang horizontal forces. So, automatic maging 0 yung ating A horizontal. Okay? And then, for summation of forces, vertical is equal to 0. So, upward positive. So, that will be AX. So, that will be AX minus 6 kilonewton minus 9 kilonewton minus 6 kilonewton plus RE. Okay? So, para makuha natin yung ating AX, so meron tayong dalawang unknown dito. So, this will be equal to 0. So, para makuha natin yung RE or either AX, pwede tayong mag-moment sa A. Kapag nag-moment tayo sa A, makukuha natin yung reaction at E. Okay? Pag nag-moment naman tayo sa E, makukuha natin yung reaction at A, yung A vertical natin. Okay? So, let us compute using summation of moment. So, mag-summation of moment at A tayo para makuha natin yung reaction at E. Okay? So, that will be summation of moment at A is equal to 0. Clockwise positive. So, always. So, ano yung mga mag-moment sa A natin? So, yung mag-moment sa A natin will be yung 6 kilonewton. So, that will be 6 times. So, ano yung distance natin? That will be 1.2 meters. So, 1.2 plus. So, clockwise siya, kaya positive. So, itong 9 kilonewton at 6 kilonewton. So, that will be positive lahat yan. So, that will be 9 times. So, ano yung distance niya? 1.2 plus 1.2. So, that will be 2.4. And, yung 6 kilonewton natin, so that will be 6 times plus 6 times 4.8. Okay. Minus yung RE natin. So, yung RE natin, mag-moment sa A, that will be negative. So, that will be minus RE times, so yung buong length ng ating truss, so that will be 4.8. So ito is 3.6 dapat ito. So that will be 1.2 times 3. So this will be 3.6. So this will be equal to 0. So mako-compute na natin yung reaction at E natin. So that will be yung RE natin will be equal to 10.5 kilonewton upward. Okay? So meron na tayong RE which is 10.5. So makukuha na natin yung A vertical natin. So this will be A vertical. So yung A vertical natin, i-substitute lang natin itong 10.5 kilonewton dito sa ating equation dito sa summation of forces vertical. So mako-compute natin yung A vertical natin. So A vertical natin will be equal to 10.5 kilonewton din. Okay? So that is the same. Upward din yung kanyang direction. Okay? So ngayon nakuha na natin yung reaction sa A and sa E nung ating thrust. Ngayon madidetermine na natin yung axial forces na nag-act sa ating members. Okay? So first, katulad yung sabi niya dito, i-isolate natin yung mga pins. So we must isolate those pins where the number of unknowns does not exceed 2. So sa method of joints, so yung joint i-isolate natin para makuha natin yung mga forces in each member. So syempre sisimulan natin kung saan tayo sisimulan natin dun sa support. So kapag method of joints, always it is possible mas okay simulan natin sa support kasi meron na tayong mga forces doon na nagre-react, no? Yung A vertical natin, yung reaction natin at E. Okay? So first is itong point A ang i-isolate natin. Okay? So i-isolate natin yung point A. So ito yung point A natin. So meron tayong force dito na A vertical. So that is equal to 10.5. And yung member natin is so we have AB and we have AF. Okay? Meron din tayong AH dito which is 0. Pwedeng kahit hindi nyo nailagay kasi 0 rin lang naman siya. So pwedeng kahit wala na din yan, no? So class, kapag ina-isolate natin yung bawat point, so nag-assume tayo ng direction ng forces natin. So always you assume tension. So kapag tension, away from the point. Okay? So always, kapag i-isolate natin yung point A and magsa-summation forces horizontal, vertical tayo, always mag-assume tayo ng tension. Kapag negative ang lumabas, so ibig sabihin, compression yung nag-act doon sa member. Okay? So in this case, sa joint A, so at joint A, makukuha natin yung force sa member AB and AF. Okay? So we have two unknowns here. So dapat possible dapat kapag nag-isolate tayo ng joint, always na two unknown lang. Okay? So unknown lang is AB and AF. So makukuha natin yung force sa force AB and force AF. So to determine yung forces sa ating AB and forces sa ating AF, so summation of forces vertical and summation of forces horizontal is equal to 0 lang tayo dito. So first, for summation of forces vertical is equal to 0, so that will be upward positive. So that will be yung A vertical natin, that is 10.5 plus So meron tayong sa force AB natin, so meron tayong vertical and horizontal components nito. So ano yung slope niyan? So kung 1.2 yan and 0.9 plus 0.9, so that will be 1.8. Yung total nito is 1.8. So meron tayong triangle. So 1.8 and 1.2. So that will be equal also sa ating 3, 4, 5 na triangle. Okay? So this is equivalent to 3, 4, 5 na triangle. Okay? So yan yung magiging slope ng ating trusses. Pwede nyong i-check yon. So this is the same din, no? So that will be 10.5 plus yung vertical component ng AB, so that will be so yung slope natin is 3, 4, 5. So vertical components will be 3 over 5 times yung AB natin. Okay? Is equal to 0. So mako-compute natin yung force natin sa AB, so that will be sa force AB natin will be equal to negative 17.5 kilonewton. So negative siya, ibig sabihin yung force pala natin ng AB is towards dun sa ating joint, or it is compression. So negative sign means compression siya. So pwedeng AB is equal to 17.5 kilonewton and compression siya. Okay? So ito yung answer natin. So next, summation of forces, horizontal naman tayo. So summation of forces horizontal, so that will be equal to 0. Going to the right is positive. So AH is 0, so that will be matitira na lang is yung AB horizontal and yung AF horizontal, so that will be AF positive. Going to the right, yung inassume natin, so that will be plus. So AB, so ano yung AB horizontal ng AB natin? That will be 4 over 5 times. So yung AB natin is 17.5. That will be compression siya, kaya negative. Okay? So yung isa-substitute natin sa equation natin is yung may negative sign. Okay? Kasi compression siya. So that will be negative 17.5 kilonewton is equal to 0. So mako-compute na natin yung force sa ating member AF. So that will be equal to 14 kilonewton. Okay? So positive yung lumabas, class, kaya AF is equal to 14 kilonewton. This is in tension. Okay? So nakuha na natin yung member AB and yung member AF natin. So okay na tayo sa AB, okay na rin tayo sa AF. Okay? So meron pa tayong natitira pang members to compute. So next na joint na pupuntahan natin will be, so dito muna nagsimula tayo dito sa baba, dito sa joint F. So kapag nandito sa joint F, so makukuha natin yung force in member BF and in member FG. So meron tayong dalawang unknown. So isolate natin. So for at joint F na tayo, joint F. So sa joint F, makukuha natin yung force ng member BF and FG. Okay. Yan. So meron tayo dito. So ito yung BF natin. And ito yung FG natin. So ito yung joint F natin. So ito rin yung AF natin. So 14 kilonewton, this is equal to 14 kilonewton. And meron tayong load dito which is 6 kilonewton. Okay? So meron tayong 6 kilonewton dito. So class, assume ulit natin, tension, yung BF natin. So assume ulit natin na tension yung FG natin. Okay? So magsa-summation of forces horizontal and vertical lang tayo. Makukuha na natin yung BF and FG. So yung AF natin is tension kasi positive siya. So away from the joint F. So summation of forces horizontal. So summation of forces horizontal is equal to 0. Going to the right is positive. So AF natin is 14 kilonewton. So 14 kilonewton. Class, papunta siya sa left side. So negative. So this is negative. Okay. So negative 14 kilonewton plus yung FG natin is equal to 0. Therefore, yung FG natin, force FG natin is equal to 14 kilonewton din. So this is in tension din. Okay? So this is in tension. So summation of forces vertical naman tayo. It's equal to 0. So that will be vertical natin, that will be negative 6 kilonewton downward, negative, plus BF is equal to 0. So same lang, BF natin will be equal to 6 kilonewton. So upward siya, so that away from the joint siya. So this is also in tension. Okay? So next joint tayo. So that will be, pupunta na tayo sa taas. So alam na natin yung member ng BF natin. So dito naman tayo sa joint B. So kapag dito tayo sa joint B, so dalawa lang din yung magiging unknown natin. So yung BC and yung BG. Okay? Dahil meron na tayong force, alam na natin yung force dito sa ating member BF and yung member AB. Okay? Makukuha na natin yung BC and BG. So doon na tayo sa joint B. Okay? So for joint B, so ganito yung itsura niyan. Meron tayong ito yung joint B natin. So meron tayong force, ito yung member natin, ito yung member BF natin. Okay? So ito yung BF natin is equal to 6 kilonewton. So tension siya, kaya away to the point. Okay? So always away to the point kapag tension. Okay? So yun yung, and yung AB natin, so yung AB natin is compression, di ba? Negative 17.5 kilonewton yung AB natin. So kung pag compression class towards dun sa ating joint. Okay? So this will be AB is equal to 17.5. And yung slope natin dito class is 345, no? Same lang din dito. So magkaroon tayong member yung member natin dito, that will be member BG and BC. Okay? So this is BG and BC. So assume lang natin na tension para mas madali natin ma-solve yung ating forces. So ma-solve natin, meron tayong dalawang unknown, BC and BG. So dalawang unknown, ma-solve natin yan. Two equations, two unknown. Okay? So summation of forces vertical. So that will be summation of forces vertical is equal to 0. So yung gagawin natin dito, that will be BC and BG. So kunin natin yung so yung slope natin dito will be 345 din. So same din dito, no? 345 din ito. Yan. So summation forces vertical is equal to 0. So yung vertical natin, upward positive. So negative BF, so that will be negative 6 kilonewton. And yung vertical force ng AB, so that will be upward, so that will be plus 3 over 5 times 17.5 and minus BG, that will be downward, so that will be minus, ano yung BG natin? Downward, that will be 3 over 5 times yung BG. And dito naman sa BC, yung vertical force niya, that will be 3 over 5 din. So yung inassume natin is tension, so magiging upward siya dito. It will be plus 3 over 5 BC. Okay? Is equal to 0. So meron tayong unknown dito na dalawa. That will be BG, BC, and BG and BC. So masosolve natin using isa pang equations. Yung so importante yung alam natin yung algebra natin na pagsosolve ng two equations and two unknowns. Anyway, pwede rin natin itong idiretso dun sa ating calculator. Okay? So next is summation of forces. Horizontal is equal to 0. So horizontal, that will be isang BF natin, hindi natin na isasama kasi nasa along y-axis siya. Okay? So ano yung horizontal forces? Yung AB natin, that will be 4 over 5 times AB natin is 17.5. Oops. 17.5. And yung BG natin, that will be papunta sa upward, ay right side, going to the right, positive. So positive yung ano natin, BG natin. So plus 4 over 5 BG plus 4 over 5 BC. Okay, is equal to 0. Okay? So we have now two equations, two unknown. So pwede nyo ting pagsabayin na i-solve and makukuha nyo na yung BG and BC. Okay? So you can input it sa ating calculator if you are using 991ES Plus. Okay? So pwede nating ma-compute using diretsong input sa calculator. Okay? Ito, kung ganitong calculator yung gamit nyo, either FX 570 or FX 991 ES. Okay? Pwede nating i-input diretso sa ating calculator. So, i-simplify lang natin yung ating equation kasi yung gagamitin natin dito is yung dito sa mode and yung number 5, mode 5, so that will be equation, and yung 1. Okay? Yung 1 yung gagamitin natin, so that will be itong an x plus bny is equal to cn. Okay? So kung mapapansin nyo yung format ng ating dito sa 1 is ax plus by is equal to c. So kailangan ganun din yung ating equation dito sa ating yung i-input natin, dapat nakaganitong format siya. So i-simplify lang natin to, that will be negative 6 kilonewton plus 3 over 5 times 17.5, so that will be equal to 4.5. So 4.5 minus 3 over 5 BG plus 3 over 5 BC. Okay? So, ilipat natin tong 4.5 sa kabila. Okay? So, itong equation 1 natin. So, let this equation 1 and ito is equation 2. So, itong equation 1 natin, ilipat natin sa kabila so that magiging negative 3 over 5 BG plus 3 over 5 BC. So, ilipat natin to sa kabila, magiging negative siya. So, transpose natin, that will be equal to negative 4.5. Okay? Para parehas na siya dun sa ating format ng ating emulator. Okay? So, mode 5 and yung 1 natin. Okay? So, i-input lang natin ito dito. Okay? So, i-simplify din naman natin yung isang equation natin. So, that will be yung isang equation natin, equation 2. So, 4 over 5 times 17.5. So, that will be 14. Ilipat natin sa kabila, magiging negative yan. So, yung matitira na lang will be 4 over 5 BG plus 4 over 5 BC is equal to, so simplify natin to, 14, lipat natin sa kabila, magiging negative 14. So, same na yung ating format. Pwede na natin itong idiretso doon sa ating calculator. Okay? So, mode 5, mode, then press 5, then yung 1 yung gagamitin natin. Then, input lang natin ito, diretso. Okay? So, that will be negative 3 over 5. So, ito muna, 3 over 5. Then, equals plus 3 over 5 BC. So, that will be 3 over 5. So, equals. And yung C natin, negative 4.5. So, negative 4.5 equals. And equation 2, that will be 4. Take note class, dapat same kung ano yung nandito sa first, sa letter A. So, kung BG yon, BG rin dapat yung nandito sa equation 2. BC, BC rin yon. Okay? So, dapat same sila. So, that will be 4 over 5 BG and 4 over 5 then BC is equal to, so, negative 14. Okay? So, press equal lang. So, makakuha na natin yung value ng, so, yung X natin, yun yung nandito sa first column. So, that will be BG. So, yung BG natin is equal to, ano yung sagot doon? That is negative 5. So, negative 5 yung BG natin. And yung BC natin is negative 12.5. So, parehas silang negative. So, they are same na compression sila. So, BG is negative 5 kilonewton. And yung BC natin is equal to negative 12.5 kilonewton. Okay? So, negative yung sign, so compression. Okay? So, that will be, yung final answer will be BG is equal to 5 kilonewton compression. And BC natin will be negative 12.5. Alisin na natin yung negative kasi isasabihin naman natin siyang compression. Okay? So, 12.5 kilonewton compression. So, kapag magsasagot kayo, class, it's either itong negative 5 or negative 12.5 kilonewton. And, pwede rin itong 5 kilonewton basta meron yung naka-close and open parenthesis sa loob, which is yung C or T. Okay? So, either. Okay, so next naman is yung point C natin. So, for point C, makukuha natin yung value ng CG tsaka yung member CD. Okay? So, isolate natin yung point C natin. So, at joint C, so, ito yung joint C natin and meron tayong, so, ito yung joint C natin. So, yung force natin dito sa ating BC, so BC, so compression siya. So yung BC natin, so ito yung BC natin. So yung BC natin is negative 12.5 kilonewton. So compression siya negative. So towards siya dun sa ating joint. So this is 12.5 kilonewton. So kung makikita nyo, so itong C natin, so CG and CD, so this will be CG and CD. So kung makikita nyo, this is symmetrical. So yung truss natin is symmetrical, okay? So kung ano yung nandito sa right side, if hahatiin natin ito sa dalawa, kung ano yung nandito sa left side, so same din siya yung nandito dito sa ating right side, okay? So same din ito. Ang slope nito is 3, 4, 5, 3, 4, and same din to 3, 4. Therefore, dahil symmetrical sila, kung ano yung value ng force natin dito sa BC, yun din yung magiging force natin dito sa ating CD, no? Pwede nyo ring i-check, mag-summation at forces horizontal and vertical din kayo. So itong value natin CD magiging symmetrical sila, so same din compression yung magiging CD natin, okay? So yung CD natin magiging same din, negative 12.5 kilonewton. Pwede nyo i-check ito, mag-summation forces horizontal kayo, okay? So pero dahil symmetrical siya, same din sila, same din lalabas yan kahit i-compute nyo pa. So negative 12.5 kilonewton compression din, okay? So solving for CG, magsa-summation forces vertical na tayo. So summation forces vertical is equal to 0, upward, positive. So yung in-assume natin is tension. So mag-downward siya. So that will be negative CG plus, so upward yung dalawang force natin, BC, so that will be yung vertical component niya, that will be 3 over 5 times 12.5 plus ganon din 3 over 5 times 12.5, okay, is equal to 0. So solving for CG, CG will be equal to 15 kilonewton, okay? So positive siya, so that will be tension, okay? So CG will be equal to 15 kilonewton tension, okay? So nakuha na natin yung force sa member CG and CD natin, okay? So kung makikita nyo class, nakuha na natin yung CG tsaka CD natin. So dahil symmetrical sila, kung 12.5 ito, so yung AB natin, force member AB natin, same lang din siya dito sa force DE natin, okay? Yung force BF natin, that will be equal din sa force ng DH natin dahil symmetrical sila. So BF is equal to BH din, okay? Yung AB natin equal din siya sa DE, okay? So itong AF natin equal din siya dito sa HE natin, okay? And yung FG natin equal din siya sa GH. So same lang din yan, yung BG natin equal din sa DG, okay? So hindi na natin kailangang i-solve kasi same din sila, okay? So i-summarize natin yung mga answer natin. So member, so mas maganda na i-tabulate natin yung sagot natin para mas makita natin yung mga values ng ating forces ng ating mga members, okay? So yung mga member natin, so that will be So, AB, BC, CD, DE. So, para mas maganda, pwede nating pagsamahin yung mga top chord, bottom chord, and yung web members natin. Okay? So, yung top chord natin will be AB, BC, CD, and DE. And for the bottom chord, that will be AF, FG, GH, and HE. And for the web members, that will be BF, BG, GD, and DH. Okay? So, ilista natin. So, yung member, so yung mga top chord muna. So, yung top chord natin will be AB, BC, CD, and DE. Okay? And for the web members naman, web members, that will be BF, BG, CG, DG, and DH. Okay? And for the bottom chord, so for the bottom chord, natin, bottom members, so that will be AF, FG, GH, and HE. Okay? And pwede natin i-tabulate. Ilagay natin dito sa second column natin is yung mga tension members, and dito sa third column is yung compression members. Okay? So yung AB natin, that is compression, so that is 17.5 kilonewton. So same din siya sa ating sa BC naman, that will be 12.5 kilonewton. Okay? So yung dahil symmetrical sila, so CD is equal to BC, and yung D is equal to AB. Kasi symmetrical yung thrust natin, no? Symmetrical kasi yung thrust natin. Okay? So, ito yung thrust natin. So, that is symmetrical sila. Okay? So, symmetrical. So, drawing na lang muna natin dito. So, that will be A, B, C, D, E. So, yung F natin, F, G, H. Okay? So, yung CD natin is equal to BC kasi sa same lang din sila. So, 12.5 kilonewton. And yung DE natin, same siya sa 17.5. Same siya sa AB. So, DE is equal to AB. So, 17.5 kilonewton. And for the web members, so tension yung BF natin, okay? So yung BF natin is 6 kilonewton. And yung BG natin will be compression siya. So that will be 5 kilonewton. And for the CG, tension siya, that will be 15 kilonewton. Ayan. And for the DG, 5 kilonewton. So, same lang din siya. Yung BF natin and yung DH pala. So, for the DG, yung DG natin is same siya dito sa BG. Okay? Ito yung BG natin. So, same siya sa DG. So, 5 kilonewton din yun, compression. And yung BF pala natin, ito, BF tsaka DH, is equal din sila. So, DH is 6 kilonewton. Okay? Ayan. And for the bottom chord, yung AF natin is tension. So, yung AF natin is 14 kilonewton. And yung FG natin, 14 kilonewton din. So, same na to, no? So, same din to, tsaka dito. Same lahat yung bottom chord natin, 14 kilonewton. Okay? Ayan. So, ito na yung tabulated nung mga tabulated answer natin sa mga member force ng ating trusses. Okay? So, ito yung magiging final na sagot natin. Okay? So, next na method natin in analyzing structures, in analyzing trusses. So, next is yung method of sections. So, situations arise when we are only interested in determining the actual forces in a few selected members of a truss. So, the method of section permits us to determine directly the force in almost any member instead of proceeding to that member by a joint-to-joint analysis. So, sa method of sections, kapag gusto lang natin kunin yung force ng isang member or selected member lang, so we can use method of sections kaysa mag method of joints tayo na iisa-isahin natin, no? For example, itong figure 4.4 natin, if we have this truss, kung gusto nating malaman yung force lang ng member FE, so pwede tayong gamitin yung method of sections kaysa gagamit tayo ng method of joints. So i-isolate natin yung point A. So after nung joint A, pupunta tayo sa joint F, no? So madaming computation din. So sa section, ang gagawin lang natin sa method of section, so maglalagay lang tayo ng sabi niya dito, in this method, some members of truss are imagined to be cut by passing a section. So parang hahatiin lang natin yung ating truss into two parts. Sabi niya rito, which divides the truss into two parts. One or more of the members that are cut by the section must be the members whose actual forces are to be determined. So class, kung saan tayo magka-cut is yun yung members na hahanapin natin, no? So example, if FE yung hahanapin natin, so yung cutting section natin dapat dadaan sa FE. Okay? And sabi niya dito, in rare instances, the cutting section may have to divide the truss into more than two parts. So, pwede pa lang more than two parts may divide yung truss. So, one part of the truss is then isolated and all forces acting it are shown to obtain the free diagram. So, pwede nating isolate. So, mahati siya sa dalawa. Example, itong truss natin. So, naglagay tayo ng cutting plane. Hinati natin sa dalawa. Selection natin. So, dumaan sa FE, BE, and BC. Okay? So, i-isolate natin yung ating truss and then pwede nating i-analyze. So, itong first part, we can analyze it. Mako-compute natin yung forces ng EF, BE, and BC. Okay? So, it is essential that the cutting section does not cut more than 3 members whose internal forces are unknown. So, sa method of section, maximum lang dapat yung isi-section natin or yung dadaanan ng ating cutting plane. Okay? So, dapat 3 lang. Hindi pwedeng 4. Okay? So, always remember that. So, the cutting section need not to be straight. Its purpose is to isolate the truss segment selected as the free body without involving more than 3 unknown. So, it is not necessary na straight ng ating cutting plane, no? Basta lang 3 members lang yung pwede nating makat at ma-divide natin yung truss natin into two or more into 2 or more parts. Okay? So, example, itong ating problems. So, for the truss shown, determine each of the forces in bars BD, CD, and CE by means of an equilibrium equation that determines it independently of the others. So, ito yung example natin na truss. So, ang required natin is yung forces along BD, CD, and CE. So, we will use yung ating method of section. Okay? So, kapag sa method of section, diretsong makukuha na natin yung forces ng BD, CE, and CD without getting yung forces ng AB. Okay? Without using the method of joints. Okay? So, let us solve it. So, first is yung reaction muna, no? Compute muna natin yung kanyang reaction. So, magkakaroon tayo ng reaction dito sa A. So, that will be A vertical. And magkakaroon din tayo ng A horizontal. And ito, roller support. So, this will be resultant ng F. Okay? RF natin. So, para makuha natin yung RF natin, we can summation moment at A. Makukuha natin yung RF natin. Okay? So, summation moment at A is equal to 0. Clockwise, positive. Okay? So, that will be 1,200. So, same lang yung distance nito, 1,200 tsaka 400 pounds. And yung distance niyan is 15 feet. So, that will be, pwede na nating pagsamahin, 1,200 plus 400 pounds times 15 feet. Okay? Plus 600 plus 200, 600 plus 200 times 15 feet plus 15 feet, that will be 30. Okay? And minus yung RF natin, so that will be RF times 15 plus 15 plus 10, so that will be 30, that will be 40 feet. Is equal to 0, so solving for RF will be now equal to 1,200 pounds. So that will be upward. Okay? So, para makuha natin yung A vertical natin, so magsa-summation forces vertical lang din tayo. Okay? So, summation forces vertical is equal to 0, upward positive. So, that will be 1,200 negative 1,200 minus 400 minus 200 minus 600. So, plus yung 1,200 natin na RF plus yung A vertical natin. Okay? This is A vertical. Is equal to 0. So, solving for A vertical. So, that will be equal to same din, 1,200 pounds. Okay? So, 1,200 pound yung A vertical natin. So, yung AH natin, automatic magiging 0 yan kasi wala naman tayong forces na nag-act horizontally. So, AH will be equal to 0. Okay? Now, getting yung BD, CD, and CE natin, you use method of section. So, yung section natin, dadaan siya dito sa ating BD, BCN, CE. Okay? So, dito yung magiging section natin. Okay? So, dyan. And, i-isolate natin itong left side para makompute natin, makuha kaagad natin yung BD, CD, and CE. Okay? So, i-drawing lang natin. So, ito yung A natin. So, meron tayong A vertical. Yung A horizontal natin, 0 din yan. A vertical natin, that is 1,200 pounds. So, ito yung joint C natin, and ito yung joint B natin. So, hinatin natin yung thrust natin. So, kapag hati natin, always assume na naman tayo ng tension yung member. Okay, so meron tayong force dito. This is BD. And ito yung magiging CD natin. And this will be CE. Okay. Yan. So, may force tayo na nag-act dito sa joint C. That is 400 pounds. And may force din tayo nag-act sa B. So, that will be 1,200 pounds. Okay. Now, solving for BD, CD, and CE. So, we can use yung equilibrium equations natin. Either summation of moment at Any point is equal to 0 or summation forces vertical and summation forces horizontal. Okay? So, ano yung pwedeng makuha na natin kaagad dito? So, yung force ng BD. No? By summation moment at C, makukuha natin yung force BD. Okay? Tama ba? Kasi yung CD at saka C, hindi na natin yan may moment. So, ang unknown na lang natin, kapag mag-summation moment tayo dito sa C, yung BD na lang yung magiging unknown natin. Tama? So, by summation moment at C, makukuha natin yung force BD natin. Okay? So, class, assume natin to na tension. Okay? Kapag lumabas is negative sa sagot natin, so magiging compression yan. Okay? So, yun, summation moment at C is equal to 0. Clockwise, positive. So, ano yung may moment natin sa C? So, that will be, yung 400 tsaka 1,200, hindi natin may moment kasi concurrent siya sa ating point C. So, itong 1,200, may moment natin. So, 1,200. So, positive siya kasi clockwise, magmo-moment siya sa C. So, that will be 1,200. Distance dun natin is 15 feet. So, that will be 1,200 times 15. And yung BD natin, no? So that will be ano yung may moment natin sa BD is yung kanyang horizontal component. So kunin natin yung slope nito. So yung magiging slope nito is, so kung 20 feet yon, 15 feet. So compute natin yung slope niya. Okay. So, kung ito yung triangle natin, so dito na lang, no? So, kung 20 feet yon at 15 feet yon, so minus 15. So, ito is 5 feet na lang yan. And then, ito is 15 feet. Okay? So, yung magiging slope natin is yung slope ng triangle natin. So, dito na lang siguro. So, 15 is to 5. Okay? So, pwede nating i-reduce ito. Okay? So, yung 15 divisible naman ng 5. So, 15 divided by 5, that is 3, di ba? So, yung triangle natin will be like this na. So, 3 is to 1 yung magiging slope natin. Okay? So, yung magiging hypotenuse natin will be square root of 10. So, yung slope nito will be 3, 1, and square root of 10. Okay? And yung isa naman, ito, yung slope natin dito will be, so 15 feet din yan. So 1, pwede nating i-diretso na yung triangle natin. So dito na lang. So kung 15 feet, divisible naman sila by itself. So pwedeng 1 na lang yan. 1 is to 1. And this will be square root of 2. Okay? So, 1, 1, square root of 2. Okay? Yan. So, diretso lang natin yan. So, yung may moment natin is yung horizontal component ng BD. So, that will be clockwise na naman siya. So, that will be plus 3 over square root of 10 times. So, yung distance nito is 20 feet. Okay? So, that is 20 feet. So, this is 20 feet. So, times 20 is equal to 0. Therefore, yung BD natin. So, dito yung BD natin. So, therefore, makukuha natin yung BD. BD is equal to negative 948.68 pounds. Okay? So, negative siya. Kaya yung BD natin will be equal to 948.68 pounds. This will be compression. Okay? So, nakuha na natin yung force BD natin. Now, to get yung force CD and CE, so ano yung pwede nating gawin? To get the force CD and BD. So, pwede tayong mag-moment sa point D. Okay? Para makuha natin yung value ng CE. Okay? So, kung in-isolate natin yan, so i-drawing lang ulit natin itong thrust natin. So, ito yung A natin. So, that will be 1,200. So, ito yung CE natin, no? So, class, kung ito yung mayroon tayong force dito, 1,200 pounds, and dito, 400 pounds. So, CE natin, oops, and CD, and ito naman is BD. So, para makuha natin yung CE, kailangan mag-moment tayo na magiging isa lang yung unknown, no? So, kailangan mag-moment tayo dun sa point kung saan hindi mag-moment yung BD tsaka yung CD. Tama? Para yung magiging unknown na lang natin will be CE. Okay? So, actually, pwede tayong mag-moment doon sa point D ng ating thrust. Okay? So, kahit in-isolate na natin, pwede tayong mag-drawing dito ng imaginary. So, yung imaginary point natin, ito yung point D natin. Tama? So, ito yung point D natin. Okay? So, kapag nag-moment tayo dito sa point D, so yung CD tsaka BD hindi na mag-moment kasi concurrent siya sa point D. Tama? So, therefore, CE na lang yung magiging unknown natin. Okay? So, yun. Mag-moment tayo sa point D. So, moment at point D is equal to 0. Clockwise, positive. So, ano yung may moment na lang natin is yung forces dito, 1,200 tsaka 400 pounds. So, that will be, so pagsamahin na natin, 1,200 plus 400 pounds times, ano yung distance natin sa point D? 15 feet, di ba? So, 15 feet din yon. So, times 15. Okay. Ano yung direction ng moment natin? So, negative siya. So, negative ito. Okay? So, counterclockwise. And then, ano pa yung may moment natin is yung ating 1,200. So, that will be clockwise yung moment nito. Sa yung reaction natin, yung A vertical natin. So, plus 1,200 times. So, 15 feet ito. And ito, 15 feet din. So, that will be 30 feet. Okay? Minus, so yung CA mag-rotate siya, mag-moment siya dito sa D. So, that will be negative kasi counterclockwise siya. So, minus CE so, minus CE times, so ano yung magiging distance natin? That will be 15. Okay? So, yung distance natin is 15 feet. So, 15 feet. Therefore, equal to 0. Compute natin yung force ng CE natin. So, that will be CE is equal to 800 pounds. Okay? So, 800 pounds. Positive siya. So, tension. Okay? Magiging tension yung ating CE. Okay? Yan for the para naman sa member CD. So, saan yung pwede natin gawin for member CD? So, actually, pwede tayong mag-summation moment or pwede din tayong mag-summation vertical forces na lang dito. No? Dahil alam naman natin yung member CE natin or summation forces vertical. No? Dahil alam namin natin yung BD at saka CE natin, pwede na lang tayong mag-summation forces vertical dito.